All right, domain and range is our next topic. We're really going to focus on domain, though, in this particular video. So the definition of domain is all possible inputs. And what do I mean by an input? Well, I really mean the x values that you can put into the function. So the x values that you can put into the function. And you might say, but when is there an issue? When can I not put a particular x value into the function? Well, the denominator sometimes has an issue. Remember, our denominator cannot equal 0. We can never divide by 0. So basically, we have to find the x value that when we plug into this, we get 0. That would be bad, right? That's going to tell us that we cannot have that in our domain. So what we need to do is kind of go off to the side and factor this. So remember, we've got a 2x squared plus 3x plus 1. This is a value of a that is not 1, so this is the long method. So I do 2 times 1, which is 2, and I've got a 3. So how do I multiply to 2 but add to 3? Well, that's going to be a 2 and a 1. So ladies and gentlemen, this is not new. This is just review. How do I do this? I split this up. So I drop down the 2x squared. I'm going to write the 2 first, so plus 2x, then the 1, and then drop down the plus 1. Okay, now I'm going to underline this and underline that. I'm going to pull out 2x, and I believe I have an x plus 1. I immediately write x plus 1, and I'm going to have a plus 1 out in front, right? 1 times x is 1x, 1 times 1 is 1. So that works. So now I just have to pull out the x plus 1 and write the final factored form, which would be x plus 1 and then a 2x plus 1. So I want to basically rewrite this denominator as an x plus 1 and a 2x plus 1. And remember, our issues are when our denominator is 0. Well, when would our denominator be 0? Well, that would be when x is equal to -1, because if I put in a -1 here, I'd get 0 times, I guess that would be -1, and 0 times -1 is 0. So x equals -1 would give me a 0 in the denominator. And what about here? Well, here we have 2x plus 1 equal to 0. Subtract 1. I get 2x equals -1, divide by 2, and I get x equals -1/2. So there are two values that we cannot have. X cannot be equal to -1, and x cannot be equal to -1/2. Why? Well, that means if I were to plug those values into my denominator, I would get 0, and I cannot have 0 in my denominator. So find the domain. Well, let me help you out a little bit. Let's just kind of consider this range of values. We're going to call this from -infinity, and then we've got a -1 is next, and then we've got a -1/2, and then we've got infinity over here. So basically, you can do from -infinity to -1, but you can't have a -1. You can have x values that are in between -1 and 1/2, but you can't have a -1/2. And you can have all the values in between -1/2 and infinity, but you can't have that -1/2, right? So how do we write this? Well, we're going to write this as the domain is from -infinity to -1, union -1 to -1/2, union -1/2 to infinity. So I'm basically saying the following. This interval from -infinity to -1 is this. This should look more like this interval right here from -1 to -1/2 is just inside here. Okay, and then last, of course, we've got this interval from here to here. Now you should remember that if it's an open kind of open parentheses like that, that means that the -1 is not included. If you had something like this, that's saying it does include it. So this is basically saying don't include the -1 and don't include the -1/2. So these are all the x values that would be okay to plug into your solution. So this right here would be your domain, all the x values that you are allowed to plug into this function. Okay, let's try another one. All right, so we know that we can factor the numerator. It's actually difference of squares. So this is actually going to become x minus 3 and an x plus 3. The denominator is a little bit more of a pain because we have to do our method of saying 2 times 3 is 6. It's a pretty 6. And then we've got a 7. So what numbers multiply to 6 but add to 7? Well, that'd be a 6 and a 1. So we know we're going to split this up into a 6 and a 1. So this is going to be a 2x squared plus 6x plus 1x plus 3. Underline, underline, pull out a 2x, you get an x plus 3. X plus 3. This would be a plus 1. So we'd have an x plus 3 and a 2x plus 1. So I'm going to rewrite my denominator as an x plus 3 times a 2x plus 1. Well, what do I have issues with, right? What are all my possible inputs? Well, they would be all values except for the ones that are going to make my denominator be 0. So what are the issues here? Well, if x equals -3 and here I set this equal to 0, I get x equals -1/2. So these are the two values that are going to make my denominator 0. So x cannot be -3 and x cannot be -1/2. So how would I write this in interval notation? Well, remember we're going from a minus infinity. What's my next smallest? Would be a -1/2 and then a 3 and then an infinity. So this range right here, I shouldn't say range, that interval would be from minus infinity to -1/2 is allowed. Union, which means put together or including all. This would be from -1/2 to 3. Union, 3 to infinity. So you're basically saying all possible values except for -1/2 and except for 3, because those are open intervals or open brackets, if you will. Okay, now I'm going to introduce something else that you have to be careful of, and that is, what about radicals? Okay, if you're talking about graphing on a real axis, you cannot have negatives under a square root. So here, x has to be greater than or equal to 0. Doesn't that make sense? Like, we can do the square root of 0, we can do the square root of 1, we can do the square root of 2, we can do the square root of 4, we can do the square root of anything bigger than 0, but can we do the square root of a -1? Well, not on a real axis, right, which is what we always have been graphing on. So we know that x has to be greater than or equal to 0, but we also know that x cannot be 4. So what does this look like? Well, let's look at our our table here. We know that x has to be greater than or equal to 0, but we know that it cannot be 4. So we do want to include all of these values right here, including 0, because x has to be greater than or equal to. So our domain is going to be from 0, and that means including 0, because you can have the square root of 0, to 4, union 4 to infinity. So the 0 to 4 is this interval, and then the 4 to infinity is this. And because we have open brackets on the 4, we're basically saying we cannot have 4. And again, this means that we can have 0. Of course, we can have the square root of 0. All right, last one. So We know that this right here has to be greater than or equal to 0. So I'm actually going to set 10x minus 1 to be greater than or equal to 0. Add 1 to both sides. Then I get 10x is greater than or equal to 1. Divide by 10. Divide by 10. I get x is greater than or equal to 1/10. Well, what does that look like in interval notation? Well, that would be from 1/10 to infinity. And we always have an open bracket on infinity because you can never be equal to it. So if this confuses you, let's look at this again. We're trying to be bigger than 1/10, and we're going to infinity. So we're basically saying from 1/10 to infinity. And notice how it says greater than or equal to, and that's because I can have a 0, and that's why I have this symbol right here. Folks, I know this is challenging. We will get tons of practice on this. I will promise you that. Thanks for watching.